Boy, today's the 18th, 12/18. T minus 7 days.
2024.
I know, it's crazy. Oof, using up all my real estate up there at the top of the TV. If you can't read those words, I think I write okay, but the first word is factorial. Okay. Factorials are things. It's a mathematical symbol. It's actually a mathematical operation, which you'll probably recognize as soon as you see it. And then there are two things that we're going to study now, probably at least for the rest of this week, and they are called combinations and permutations. And so, anyone know the difference between a combination and a permutation?
Combination is zero left.
Actually, yes, and that's more of a permutation, but yeah. There's a distinct difference between a combination and a permutation. You'll see. I got to pause this real quick. Pause.
You'll be here for a little bit.
So first, let's talk about the long F word at the beginning, factorials. And so a factorial symbol is just something that you're going to use. I will tell you this. I don't want this to be like a secret or anything. Your calculators will do factorials for you. However, I'm going to show you today mechanically how to do factorials and combinations and permutations by hand. If for no other reason than because I think, well, what happens, and I know it's the old person thing to say, but like what happens if I find myself on quiz day and for whatever reason or some other point in time you have to do one of these things and you can't find a calculator that does. I know it's such a 1978 thing to say. I get that. But we're going to focus today on sort of the more manual aspect of these things. And then once you get cooking on your calculator, they go a lot quicker. So first off, the factorial symbol is this. I know that in English, we refer to that as an exclamation point. In mathematics, that symbol has nothing to do with the volume of your voice. It is merely, it's a symbol. It's a mathematical operation. And here in about a minute or two, you're going to be as familiar with it as you are with like a times sign or a plus sign or an exponent or something like that. So if I were to put this down, let's see if that rings any bells, and maybe you could say, oh, I've seen this before. 5 factorial equals 120. Any thoughts on what that could possibly mean? Nope. Let me make you a list of some common factorials and see if that helps. And what I'll do is I'll grab this one and I'll move it down a little bit, and I'm going to work my way down to it. There's part of me that says, I could just tell you what it means, but it's always fun to kind of see if you can decipher it on your own. So right above that, I'm going to put 4 factorial. And I'm going to tell you that that equals 24. And above that, I'm going to put 3 factorial. And I'm just going to straight up tell you that that equals 6. And then there's 2 factorial, which again, I'll just tell you equals 2. And then there is 1 factorial, which just equals 1. But this 6 factorial is 720. Anything yet? Like, it's not normal for me to, or it's not reasonable for me to expect that you would just crack the code. But the symbol has a very specific meaning. Okay, well, I don't want to torment you with that. I'll just kind of let the cat out of the bag here. But the factorial symbol says to multiply a number by every whole positive number less than itself. And the reason I say positive is because you'll see if we were to infect the answers to these with zeros, then all factorials would equal 0. You'll see what I mean. So for example, here's what 6 factorial looks like. It says to start at 6, and now multiply 6 by all of the numbers less than him until you get to 1. So here goes. 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial looks like if you write it out. Does that ring any bells yet? It's okay if it doesn't. Yep. Correct. And so if we went up and let's say we just wanted to complete 4 factorial and be like, hey, why does it equal 24? Well, it's because I start at 4. Since 4 is the number that I'm factorialing, not sure if that's a verb, but if I hit the factorial on 4, it just says, okay, everybody start at 4, scaffold your way down. So here we go. 4 times down 1 times down 1 times down 1. And again, you have to stop here because if you go to 0, 0 turns everything, wipes everything out, right? And then you check the math on that. 4 times 3 is 12. 12 times 2 is 24. And then, of course, you could fill in 5 factorial. If you wrote 5 factorial out, it would be 5 times 4 times 3 times 2 times 1. Okay? What about 3 factorial? What would that be written out? 3 times 2 times 1. How about 2 factorial? And then, of course, 1 factorial is just, it is what it is. That symbol is important to me that you understand what it means because it's going to be in the formulas that I have to teach you. This isn't so much a formula as it's just like an introduction to a new guy. From this point on, when you see this symbol, you know it has nothing to do with volume. It has to do with, oh, that's a mathematical statement that you want me to multiply the number before it by all of the numbers that come after it until I get to 1, right? They get big in a hurry, by the way. If you think about like 7 factorial, I mean, think about it before I write down what the answer is. Just think about what it is it's basically just 6 factorial, right? You see that? But I just have to multiply it by 7 because to do a 7 factorial, again, is just a 6 factorial bumped up by 1. So if I take that, I get 5,040, I believe it is. 4,900 plus 140 is 50. Okay, let's press on. Let's get some of these into our notebooks. And again, I understand that often you're going to use a calculator. I am totally at peace with that. But if you think about like, okay, how could I build an 8 factorial? Well, that's easy. I just take my 7 factorial. And then I buff it at the beginning by multiplying it by 8. Okay. They grow quickly. And when you see the applications of factorials, I think you'll enjoy it. Like rarely does math feel like something where you can kind of jaw drop and go, wow, that's really cool. Some of this stuff that we do, maybe not today, but a lot of what we talk about with this stuff is very neat. And I hope I can get a little bit of that into your heads. So anyways, what does this one come out to?
Yeah, this one is really good.
All right, let's head on up the road to, let's go through like 10, okay? They get really obscene right about this point. So let's do 9 factorial and 10 factorial. So if I wanted to do 9 factorial, I'm going to write something down in purple, and I want you to tell me if you have an issue with it, okay? Do you have any issue with that? If you think about what 9 factorial is, right? Remember, it's just 9 times 8765432 and we already know the answer to 8765432 right? So why not just take 9 times that? What does that come out to? 362,880. And honestly, I shouldn't really even need a calculator for this last one, because if we think about what 10 factorial is, in mathematics, someone taught you that multiplying by 10 is pretty straightforward, right? If it's a decimal number, you move the decimal, but if it's a whole number, you just add a 0. And so if I said, okay, hey, what is 10 factorial going to look like? You're like, well, I got this. I'm just going to take my previous answer, which is 362,880, and I'm just going to multiply it by 10. 10's the new guy. Correct. and so on and so forth. You see factorials are going to grow quickly, right? You get up to still like 13 factorial and it's already like, come on, give me a break. It's insane. And it's already pretty insane to think about this. And when you think about like one of the things I'm going to teach you guys is I believe there are 9 students in this room. Does that sound correct? Yeah, there's 9 students. And then there's myself and Miss Orozco. But would you believe me if I told you that if someone from the yearbook staff came in here and said, I need to take a picture of every student put together in your 7th hour class, but my editor is really picky and she said she wants to see all 9 people in your class in every different possible order. You think that would have a lot? How many you think it would have? Like imagine if a yearbook person walks in and said, okay, I'm going to put 9 chairs along the back wall over there. And here's what I need you guys to do. Just pick them, go find your seats, sit down, and they're going to take a picture. And then they're going to say, okay, get up and rearrange yourselves. And then go take a picture. How many different pictures do you think they'd have to take to cover all 9 of you arranging yourselves in those chairs? That is correct. There
Oh,
are
that's too many.
362,880 ways that just the 9 of you could arrange yourselves for a photograph. That's a nice, fun application of factorials. What if a 10th person came in? What if Miss Orozco wanted to be in the photograph? Now, how many ways are there? Correct. It blows the mind. And I'll show you when the time comes, not right this second. I'll show you exactly why that works the way it does. But anyways, that's what a factorial symbol is. Got it? Okay. So now we're going to talk about permutations and combinations. And let's do combinations first. So combinations.
Ow.
You're going to want to underline this in red.
How many your pens?
What are you talking about?
I'll go right there. The bucket.
So a combination is a group of people or items or cards or numbers or letters or anything that you can select from a larger group where you don't care about the order. Let me give you an example of something like that. So here's an example of a combination. Let's say you had the letters A, B, C, D, and E. And you put them on maybe like a card or something like that. Like you have 5 different cards. And if I wanted to make a combination, we would say, how many combinations of 3 are there? Now, there's a mathematical way to do this, and there's a manual way to do this. We're going to do it the manual way first, and then I'm going to show you this formula that's going to make you probably say a dirty word until you learn how easy it is. And then it's going to get even sweeter when you see how quick your calculator will help you with it too. So in the meantime, here it goes. Here's what a combination feels like. It means I could reach into a little hat. Say I had these 5 cards in a hat, and I reached in, and one possible combination is that I could pull out the A and the B and the C. What's another combination? And be organized, please. Don't spout off some random thing about B's and E's and D's. Try to stay organized. What's another combination of cards that I could get? Excellent thing to say. I'm going to write this down, and I want you not to write this down. The next thing I heard, and I heard some other ones, but this one caught my attention. Why is this not another combination? Because it's the same combination. And again, that's why I had you underline those 3 words. Order doesn't matter. Listen, if Trinity reaches into the hat and pulls out A, B, and C, and then she puts them back in, and a minute later, Dietrich pulls out C, B, and A, They have to agree, oh, we got the same combination of cards. When we get to permutations, that will be a different thing, but with combinations, that's the same. When I say I want to be organized, let me show you what I mean. This is how I make an organized list. Is there another combination of cards that would start with the A and the B? Is there another combination that starts with the A and the B? So when we talk about making an organized list, it's best to try to use up as much of the same stuff as you can while changing only a little bit at the back. Are you with me? Are there any other combinations that involve the card A? Yes. Again, let's not start going out of order. If we're going to get through this, we have got to think linearly, like left to right. Thank you. Who's to say that I can't have A and then C and then D? That combination has not been dealt with yet. What's another combination that starts with A? C. Trust me, if you're going to get through this, you want to keep as much to the left consistent as you can, and only change the little tiny bits necessary, or you will find yourself skipping over large chunks of answers. And there is one more combination that involves the card A. What is it? AAA cannot count because that's the same thing 3 times. Like you can't pull out 3 copies of the same thing. There's one more combination that involves the letter A. What is it? Micah, you tried to say it earlier. A, D. There is no other combination using the letter A on the board. But that's not to say now, let me switch colors. I could also now come up with some combinations that start with the letter B, right? What else could I pick? B, C, D is the best perfect first answer. Look how logically that fits. They're right in a row, side by side by side. What else could I pick? Good job staying consistent. Keep the B and the C the same, but let's get an E in there. That's another combination. There are no more BC somethings. Why couldn't I say BC? Yeah, backtrack to A. Why can't I say that? Because I've already used it, ABC. So if you are organized about this, which is why I'm going to keep saying this, if you're organized, you will never have to backtrack because you've already like milked everything out along the way as you go. If you find yourself having to backtrack, then you need to work on your organization skills. But there is one more that starts with B. What is it? It is B, and then jump across to the D, and then the E. And there's no more, again, because you have to backtrack to come back, and it's already been done. That's everything with B. The last one is CD. Got it? It's important to me that you do what Micah just did and that you go through and you count these up. And then we're going to go through and do something that I hope you find to be interesting to verify that this is pretty legit. But yes, if you count these up, guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We should proudly state that there are 10 combinations of 3 cards out of a set of 5. So far, so good? Okay. Now I'm going to show you a formula.
Formula.
You should write that down.
Is that N?
That is a little NCR. And don't worry, this is going to make more sense here in a minute, I promise. NCR. So that's a little lowercase n, big capital C, and then a little subscript lowercase r. So the n's and the r's are like little subscripty guys. And then to calculate NCR, what you do is you take the factorial of n on top, and then you take a factorial on bottom, but it's of n minus r. So you might go, oh my God, this lesson just took a turn for the crackhead. Like, what's he talking about? But wait, it's not bad. Let's compare this now. Let's apply this to what we just did. In the previous example, how many cards were there? There were 5. And how many were we making combinations of at a time? So the math problem we just did was 5C3. Stay with me. Combination. This is combinations. We haven't touched on permutations yet. In fact, I don't know that we will necessarily today. So let's ride these combinations for a few more minutes and get comfy with them. The fact that you see a C is a combination, when we switch it to the permutation formula, we'll switch that to NPR, like National Public Radio, right? So what the NCR is it's saying, okay, the N stands for this. How many items you have total. The R is the size of your groups. And the formula is like, I got you. Here's what it says to do. On top. By the way, when you see 5C3, do you agree then that N is 5? What's going to go on top of my fraction then? Factorial. The formula actually involves factorials. Isn't that amazing? And then on the bottom, I have to take a factorial, but first I have to do a little bit of second grade math. What is N minus R in my purple example? What is 5 minus 3? It is 2. And I got my formulas backwards. Are you all still with me and listening? I need you to add an extra factorial in here, right at the beginning of the bottom. I usually do permutations first, so I messed myself up. I'm going to point to it with a yellow arrow. Does everybody see the new guy right there? He infiltrated my formula. So we also have to add him into the bottom. So in the bottom, yes, we have 2 factorial. I'm going to slide him aside a little bit. And then we also have another factorial on bottom. And what is that? So n minus r, let me color code this for you. So n minus r factorial, I'm underlining it in red, is the same as what I underlined in red, because that was 5 minus 3 is 2, right? And what does this other one say right here? I'm circling it in red. 3 factorial. Very good. So far, so good? So the formula, my apologies for that, I threw myself off there, is NCR is equal to n factorial over, and then you have to put 2 factorials in the bottom. One of them is just generic r factorial, and one is n minus r factorial. Now, help me with this. Help me write out 5 factorial. Would you please be so kind? What is 5 factorial? No, help me write it out, please. What is it? What is 5 factorial? Good. I'm showing you a shortcut. Eventually, we're not going to use these shortcuts because we're always going to have our calculators. But I'm just, again, doing my due diligence here and preparing you for the worst. Kim, please don't say 6 to the following question. Help me write out 3 factorial. What would it say? And finally, please, if you'd be so kind, help me write out 2 factorial. What would it say? Good job. So you ready? If you don't find what's about to happen to be interesting, I would understand. I'm not going to be offended. But I hope you have a moment of kind of mental, kind of get perky, because it's neat. So here it goes. You guys know that with fractions, you can always reduce, right? And reducing just means to divide things out of the top and the bottom that are the same. Well, tell me if you think I'm crazy. Isn't that red box the same as that red box? Am I wrong? Am I seeing things? Then why don't we just take that and cross it off like that, cancel it. Now, I also happen to know, since I passed grade school, that this number that I'm going to circle in yellow can reduce with this number that I'm going to circle in yellow. If I reduce that 2 and that 4, divide them both by 2, what does the 2 on the bottom become? And what does the 4 become? And at this point, I'm pretty certain that that's like all the meat that's left on that bone, right? So if you multiply straight across the top now, what is 5 times 2? 10. And on bottom, what is 1 times 1? And what is 10 over 1? And that should be interesting to you. that just now when we counted them all out, we got 10. We did it old school by just counting it out, and we got 10. You follow? Let's practice this process again. Only this time, let's say we have A, B, C, D, E, F, G, and H. Got it? So this is my collection now of cards, and we are going to pick them out 5 at a time. 5 at a time. Now, because I like you guys and I am not out to make enemies with you, that's the last thing I want to do. We're not going to do this one by hand like we did the last one. Like, I'm not going to have you go through and say, okay, here's a possibility, A, B, C, D, E. Here's another one, A, B, C, D, F. Here's another one, because that can get a little bit tedious. We could do it. Let's do it with the formula instead. So when I go to set this up, I'm going to set it up as, how many cards are there? 8. So I'm going to set it up as 8C5. You agree? Okay. And again, sorry for the botched formula. Hopefully it's accurate in your notes now. So here we go. I'm going to have a fraction. And don't remember, you understand now, I don't want you reading me like, what the answers to factorials are. For now, what is going to go on top of my formula? And let's just start by just writing them as factorials so no one gets confused. We agree, according to the formula, that n factorial, or in our case, 8 factorial, goes on top. Now, on bottom, you want to put a times sign right here like this. And you have 2 factorials to put on bottom. What's the first one? 5 factorial. Very good. And to get the second one, I'm going to go in yellow over here and circle these 2 numbers. What is 8 minus 5? So your other factorial is 3. So far, so good? All right, then let's go write this out now. Now it's time for you to tell me and show me that you know what factorials look like. And so here it goes. What is 8 factorial written out, not the answer? Excelente. Muchas gracias, señor. And what is 5 factorial on the bottom written out? And finally, what is 3 factorial written out? So let's talk bang for the buck. I'm always going to go where I can get the most bang for my buck. Look at this. Look at this chunk in the red box. Can you find another one of those? Yeah, let's just go take it right off. Just peel it right off the back. Look at that. This 5, 4, 3, 2, 1 on the bottom, ka-chunk, 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 perfectly kills the 5, 4, 3, 2, 1 on the top. And I see some really good news. What is 3 times 2? And it just so happens that there's a 6 on top. So that 3 and that 2 can entirely murder off that 6, leaving us with a, thank God I passed my 4th grade times tables test. What is on top? 8 times 7.
56.
So if just now we had sat here and counted out all possible 5-card combinations out of that set of 8, we would have arrived at a list of 56 items. Now you can apply this to other things. Let's say you have 14 what you would consider to be close friends. Got it? Win a trip. You win, like, you enter this contest like a raffle, and you win a trip for you and 3 friends, the Super Bowl. So the math question is as follows. You have 14 people that you consider friends. You probably have a lot more, maybe acquaintances. But when you sit down and really think about like, who do you care about? Who's nice to me? Who am I nice to? Who do I do things for? Who does stuff for me? 14 people come to mind. Okay. Now you've got a pressure situation here. You win a trip to the Super Bowl, all expenses paid, airfare, hotel, tickets to the Super Bowl, souvenirs, all that stuff is paid for. But you can only take 3 friends to the Super Bowl. First off, do you see why this is a combination problem?
Easy. Me, myself, and I.
Why is this a combination problem and not a permutation? Yes. Here, how about this? Let me. I can't get upset when you say stuff like that because I'm the ding dong that put it there. How about this? How many groups of friends? There you go, smarty pan. So at the beginning, when we defined what a combination is, what did we say about combinations? That's the magic, and that's going to be the thing that gets us through. Order doesn't matter. So like if you pick these 3 friends, like if you pick Mike, Alicia, and Helen, that's the same as picking Helen, Alicia, and Mike, right? Like the order that you pick them in doesn't matter. So this is a classic combination problem. Let's get it set up. Set it up. We're going to set it up as 14C3. Get used to that notation. There are 14 friends in my group, and I can only choose 3, right? You don't have to choose yourself, of course. You already get to go.
What if I just want to take myself? Me, myself, and I.
What's going to go on top of the fraction? 14 factorial. Very good. And then always remember that on the bottom, you're going to have your 2 factorials. And that will not be true when we get to permutations, FYI. So the first thing I'm going to put on the bottom is what? Yes. So there's going to be a 3 factorial. Remember, this is where we put our R factorial right there. The group size goes there as a factorial, but then the other one we get by doing basic subtraction. What is 14 minus 3? Good job. You getting the flow of this? Okay, so here it goes. This is always the part of the lesson where I lose people. So prepare yourself. You're about to get lost. Are you ready? Please go ahead. Yes. Yes. There it is. Now you're going to fall into one of 2 categories. Here in about a minute, you're going to totally understand why Micah did what he did, or you're going to say something like, what in the world just happened? Micah is spot on. And there's a reason I don't want you to do this until like our 3rd or 4th example together. But this time Micah's like, wait a second, I see the writing on the wall. If this 14 factorial on top, can't I just put 14 times 13 by 12 and stop? Why? Well, there's to be 11, 7, 9, 8, because it's going to happen right there. You agree? So if you know you're going to write 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 on the bottom, why not just stop before you even write it on top? It seems a little insane to me to write out 11 through 1 on top and then just turn around and write 11 through 1 on bottom when you know you're just going to put a big old X through them anyways. Good job, Micah. So I can stop at 14 times 13 times 12, but that does not get me off the hook for this 3. The 3 is still 3 times 2 times 1. What is 3 times 2? And that 6 can go into that 12. I can make the 6 a 1 and the 12 a 2. Because you're fine, you're fine. And we divide by 6 and we get a 2. And then at this point, my job now is to say, okay, I'm going to multiply everyone that survived. Your goal is always to get the bottom to be 1s. If there's ever anything in the bottom, trust me, you can cancel it out. So now let's multiply. 14 times 13 is 182, I think. And then 182 times 2 is 364. You might want to check my math on that. That means if you have 14 people that you consider your friends and you win a ticket, you win a group prize, yourself and 3 friends to the Super Bowl, you have 364 different groups of friends you could choose. That's a lot of pressure. Yeah. Got it? Would you like to learn about permutations today? Should we just should we cross over? Let's practice some more of these. Tienes que salir. not going to tell you that yet. I really, for now, I'm going to stay away from the calculator. I hope you understand that that's not like a power move or something. I'm going to have you get really good at it like this. And then I'm going to show you calculator will do the whole dang thing for you. Just FYI. I just don't like the idea of like not knowing a little bit about what's going on under the surface. That's never felt good to me. So that's why we're going to practice. Adios. Try this one. Give it a go. Without my help this time, 10C4. And that can be modeled as anything. I got 10 somethings. I got 10 shirts, but I'm only allowed to bring 4 of them on my trip. Like, how many groups of 4 shirts could I pick? And again, I say that because order doesn't matter, right? Anyone get an answer yet? Wait until you see Pascal's triangle. If this hasn't been impressive to you, if you're not like, that's kind of cool, Pascal's triangle is that's gonna be the one that tips you over. What's that? Micah says the answer is 210. I shall neither confirm nor deny that that is the answer. I leave it to you to see if you can come up with anything else. Is that what you got? Written out on top, you should have 10 factorial. The very first factorial on bottom should be 4. Second factorial is 10 minus 4, which is 6. And again, we think Micah really opened the door for this. When I start to write the 10 factorial on top, I am going to write 10, 9, 8, and 7, and then I'm going to pump the brakes because I know that I'm about to write a whole bunch of crap that I'm about to write again on bottom, and they're just going to cancel out. So then that leaves me with only having to write the single, the R factorial on the bottom, the smaller one, if you will. So 4, 3, 2, 1. And then you can get creative with this and pair it off. What I like to do is just think about like, how can I be creative? And so, like, for example, this 4 and this 2 make 8, right? So that entire 4-2 combo of 8 can just murder that 8. And then there is no 3 on top, but rest assured there will always be something that plays nice. If you're doing things right, there will be. This 3 can become a 1, and this 9 can become a 3. Got it? And then, of course, yes, 10 times 3 times 7 is, in fact, 210.
Oh, I did it kind of.
Did you cancel things differently? That's okay. Yeah, it's all going to come out in the wash. If you gave that statement, if you gave this problem right here to 20 different people, I would expect that you'd come up with 10 or 11 different strategies to simplify it down. Got it? If it works, it works. You bet your butt. Okay. Let's do one more, and then I'll be done with you for the day, and you can just play on your phones or something for like 7 or 8 minutes. Sound good?
Yeah.
All right, let's do 12C7. Oh, I see what you did there. My son came home from college last night and then got to have his wisdom teeth out today.
Oh, best Christmas present ever.
I know both my kids went in today. One of them only had one that had to be pulled, but my older one, Josh, had all four. Huh? Not yet. No.
What doesn't it doesn't Josh?
No, Josh is a junior at UW. Not quite that old yet, Peyton. What are you saying? I'm like 64.
I thought you told that. The thing over there.
No, that's when he was literally in the 6th or 5th grade when he was a kid. His class made that, not his class like as a teacher. He was a student in the class that made that. Little kids, like 10-year-olds. Say it again. All right, we have an answer on the board. Again, I shall not emote in any way to give off any inclination as to whether that's right or not right. 792, though, is on the board. As I start working through the process, it's all about knowing the formula. You know, your original, your big group number is going to go on top. So on top, I'm going to put a 12 factorial. And then on the bottom, I'm going to start by putting the factorial of just the second number. And then I'm going to multiply by the difference factorial. 12 minus 7 is 5. I always say, like, look for the bigger of the two factorials on the bottom. And so when I start writing out the top, I'm going to only write out 12, 11, 10, 9, and 8, because I know that everything that would come after that is going to be canceled by the 7 factorial on bottom. That leaves me with then only the 5, 4, 3, 2, 1. And again, feel free to, could you guys wait just one? I'm not quite done. I don't know what's happening. You're really freaking me out here. Like, I don't know. So the 4 and the 3 are going to make a 12. The 5 and the 2 are going to make a 10. And then you multiply those together. So again, you probably canceled a different way from that, but it's okay. So that was the mission for today. You now know what the factorial symbol means, right? And you know how to do the NCR formula for combinations. I'd say that was productive. So yeah, you can have 5 or 6 minutes